So this is the second video in implicit differentiation, and I'm going to do these three problems. They're a little bit more involved, and I threw them some trig with it and some exponential functions for some practice. So here we have the cosine of xy. I can tell it's implicit in because I've got my xi's are mixed, equals 3y plus 3. So we're going to start this. Now if you look at this right here, I know the derivative of cosine is negative sine, don't touch anything in the parentheses, times the derivative of the inside. Now the inside is the product rule, and if you remember we just did this in the last problem, but if I let f be x, f prime is going to be 1 dx, or just dx, g is going to be y, g prime is going to be 1 dy. So when I do f prime g, I get y dx plus x dy. After a while you'll get used to this. And always put the d whatever behind your variable. Equals, the derivative of this term is going to be 3 dy, that's dy, plus 3, so it's going to be 0. Now, here's the hint I'm going to tell you. Right now you have a term times a term. What I would suggest is you multiply this through, and when you do, make sure the dx and dy stay at the end, and put like your coefficients, your variables in the front. So I'm going to, this first term I'm going to write as negative y sine xy dx minus x sine xy dy equals 3 dy. So I didn't divide through by dx until I got that. Now that I have three terms, I'm going to divide through by the dx's. And if you'll see here, thanks for playing, I have two terms with a dy dx. So what I'm going to do is so if you look at this, this is a term right here, this is a term right here, and this is a term right here. So I'm basically want to solve for dy dx, so I'm going to move that whole term on this side, okay? So I have negative y sine xy equals 3 dy dx plus x sine xy dy dx, because it changed signs when I went over to the other side. Now, notice I have a term here and a term here. How am I going to how am I going to isolate my dy dx? Is I'm going to factor it out. So if I pull out the dy dx, I have 3 plus x sine xy here, and this is minus y sine xy. Alright, now I want to solve for dy dx, so I'm just going to divide by this. So I have dy dx equals negative y sine xy all over 3 plus x sine xy. Now you cannot do this any differently, because this is a whole term, a term, and a term, and I can't factor anything out of all three of them, so it stays the way it is. Okay, let's try this one here. So I'm going to take the derivative of this. It's implicit again, but I'm going to do the power rule first. So I'm going to take 2, don't touch anything in the parentheses, raised to the first, equals 6, times, here I want to take the derivative of the inside. The derivative of the inside is going to be 3 dx plus 1 dy. Okay, equals 6 dy. Tried to rush that. Do not divide through, first multiply through. Okay, so I have 6 3x plus y dx, put it in the back, plus 2 times 3x plus y dy equals 6 dy. Now you have three terms. Go ahead and divide through by dx. So you'll notice, thanks for playing, that's gone. Again, I have the two terms here that have dy dx, so I'm going to move this whole term right here, including the dy dx, all the way over to the other side. So I have 6 times 3x plus y equals 6, okay, dy dx minus 2 3x plus y. It's a plus. Come on, it's a plus. Dy dx. Now again, we're solving for dy dx, so you guessed it, we're going to factor out the dy dx from those two terms. So I have 6 minus 2 times 3x plus y here. And this side is a 6 times 3x plus y. Sorry, I lost my place there for a minute. Now I'm going to divide by this whole term that's hooked to the dy dx. So I have dy dx equals 6 times 3x plus y all over 6 minus 2 times 3x plus y. Now that's not incorrect, but if you look at this, I have a term here, a term, and a term. And all those three terms I can divide by 2. So you can really say it this way. dy dx is going to be 3 times 3x plus y all over 3 minus 3x plus y. And that is our derivative. All right, we have one more. This one I have an exponential function in it and a trig function. So the derivative of this whole thing here is going to be cosine, don't touch the inside, times the derivative of the inside, which is 1 dx plus 3 dy, equals, now if I go to do this exponential function, I got to rewrite it times the derivative of the front. So I'm going to say 2e to the 2x, but don't forget your dx here. Again, make sure you multiply through before you start dividing by dx. So I have cosine x plus 3y, cosine x plus 3y dx plus 3 cosine x plus 3y dy equals 2e to the 2x dx. Now I can go through and divide by dx because all my terms are out there. And this one's a nice one because thanks for playing here and thanks for playing here. So basically I've got just dy dx here. So I'm going to take this term right here. This is my strategy. I'm going to move it to the other side. So I end up with 3 cosine of x plus 3y dy dx equals 2e to the 2x minus cosine x plus 3y. Alright, so then I got to solve for dy dx, so I'm just going to divide by the parentheses. So I have dy dx, this one looks ugly, equals 2e to the 2x minus cosine x plus 3y, all divided by 3 cosine x plus 3y. And that is our derivative because there's nothing I can divide with all the terms, so that's it. That's the end of this video. I'm going to do applications on the next one.